So in this demonstration, what I'd like to do is enable the state table for ICMP traffic. So here's our drawing that we're working with. This is our diagram. And what I'd like to do is I'd like that inside PC to be able to ping the web server and the internet PC and the outside web server. I want to be able to ping all of those addresses if possible. Right now, I'm unable to do that. As I told you before, I've been testing with HTTP the whole time because ping is explicitly blocked on the firewall. So let's go in and enable that and make pings work to our devices so that we have a much more effective troubleshooting utility than having to have web servers all over the place. I'm going to open a command prompt and we're going to send a ping message to a couple devices. One is my internet PC, ping 198.19.42.33 -T. I'm going to open a second prompt here. And this one, we will ping 198.51.100.100. Oops, we want to add the -T on there. I want this to be continuous. And we'll open up another window. And this one I'm going to ping 192.168.42.80 and we'll put that one here. So right now you can see that all three pings are failing. That's all requests timed out. What's happening is the firewall is dropping these ping messages because it has no state table for them. If I go to my firewall console to get some configuration done, what I do is on the Cisco firewall, I'm going to create something called a service policy. On other firewalls, this is enabled in different locations. You'll have to consult the documentation for your specific firewall to do this. If you have a Cisco ASA firewall, you add a service policy. We're going to create a global service policy to apply to all interfaces for this example. Keep it simple. Here we have to tell it what traffic should we inspect. And we're just going to do the default inspection traffic, which includes ICMP. So what the firewall is going to do is it's going to pay attention and watch for ICMP traffic so that I can put it through this separate policy. Next, it just tells us what protocols it's watching for. One of them here that we want is ICMP. The next step is saying, all right, well, what inspection do you want to do? We specifically want ICMP inspection so that we can keep track of the ICMP state, and we can finish and apply that. Now, those policies can be applied for all kinds of things, including TFTP and other applications, as well as FTP if you need to. FTP is a little bit goofy, and we can actually set up a service policy to deal with FTP traffic as well. But what I should see happen now is after I've applied this, is I should be able to drop this down. And now I see replies from 192.168.42.80, my inside web server. I see reply from 198.51.100.100, which is my outside web server. I'm still getting requests timed out here from my internet PC. Let's see if I can fix that. And right now what's going on the internet PC is the firewall is on. So I have a firewall on my inside PC, which is denying my ping messages. If I turn that off, we should quickly see my ping messages get replied to here, and there they come. So there the issue was that I wasn't getting replies because my Windows internet PC had its firewall enabled, so it was dropping those ping messages. But once I enable that service policy, you can see that ping starts to operate. This is a way more effective way of troubleshooting networks using ping versus using web servers everywhere. Ping and ICMP do have some vulnerabilities and some security issues, so you and your organization have to figure out whether or not allowing this is a valuable tool or not. My perspective is that it is a valuable tool. Many users know how to use ping to check for connectivity. If ping isn't working, it could actually increase help desk calls and things like that. Let's wrap up this section.